All right. I wanted to give you guys a little bit of clarification on some of these topics we've been going over. Our radicals. Um, First off, I know you know how to distribute, right? So I said you got a 2 times x minus 7. You would know to multiply that 2 times the x and 2 times the negative 7 and tell me that that was 2x minus 14, right? Boom. You would do the same thing if I said, okay, you've got a radical 5, and you're going to multiply that and distribute it to the radical 3 minus radical 15. You would know to multiply the radical 5 times the radical 3 and to then distribute the radical 5 again times the square root of radical 15. The only thing with radicals are, what do we remember? We're always looking for twins. So when the radical 5 and the radical 3 end up in the same prison, they're not twins. They're not going to be able to simplify each other. When the radical 5 times the 15, though, meet in the same radical prison, though, it will have a set of twins. It will have 2 twin 5s. So one of those 5s is going to come out. One of them is going to get shot. And so we're going to have radical 15 minus, who came out? Radical 5. One of them came out, so it's now a free 5. Radical 3 is left behind. And that would be our answer. Okay? So, same thing over here. By radical 7 times radical 3 plus radical 14. Don't try to add the radicals up together. They're two different radicals. Just distribute the radical 7. All right? Radical 7 times radical 3 plus radical 7 times radical 14. All right. Now again, 7 and 3 are prime, so they're just going to go under the same radical and become radical 21. Plus, now this is where you got to be careful. Think about that 7. Factor 14. 14 is 2 times 7, or 7 times 2. So 2 7s, 1 will come out, 1 will get shot. So radical 21 plus 7 radical 2. Would you maybe see the answer the other way around? Sure, you might see 7 radical 2 plus radical 21. Either answer is okay, though. Right? Order doesn't matter when you're adding. All right, so here is the tricky part. These conjugates. If you've studied language, you've heard about conjugating verbs. The same thing kind of applies towards math. It's a different form of something else. All right, so the conjugate here is a plus c radical b times a minus c radical b. So depending on what you start with, if you start with an addition or if you start with subtraction, the other one's going to be the kind of opposite of the other. But please notice that everything that's not the sign is exactly the same. Okay? And when we multiply these out, this is going to be just like when you factor difference of squares. You go, wait, what's the difference of square again? Well, that was an a squared minus b squared factoring to an a plus a b times an a minus a b. Do you remember that? Yeah. So this is like your a plus your b. This is like your a minus your b. So when I FOIL these out, when I FOIL them all out, right, the two middle terms are going to go away, and all I'm going to be left with is a squared minus b squared. So in this case, right, I got to be really careful though. What's my a squared? Well, my a is a times a. All right, and what's my b squared going to be? That's going to be minus, so remember it's going to always be minus because different signs, so the second term is going to be subtracted by c radical b times c radical b. All right, this is where you got to regroup things though and say, okay, c times c is going to be c times c is going to be c squared, right? And radical b times radical b Let's see, how's that going to work? Well, this is going to become a squared minus c squared. And then this radical b times radical b, that's going to be 2 radical b's in the same radical prison. One's going to make it out. One's going to... So the b is free. A squared minus c squared b. So if I'm looking at just letters down here, wait, what does that mean? It means if this is your A, this is your B, and this is your A, and this is your B, A squared minus B squared is going to give me A radical B times A radical B minus C radical D times C radical D. All right, so what's going to happen? Well, I just did that one over there, but with a B instead of a D. So this is going to be minus C squared D. So this one's got to be A squared B. And I think it's actually harder with the letters than it is with the actual values. All right, so first off, if this is 3 plus 2 radical 3, what's its conjugate? If that's an A plus a B, 3 plus 2 radical 3 has to be multiplied by what conjugate? Well, the A is the 3, right? The B is going to be the minus 2 radical 3. Now, instead of foiling out all 4 terms, I'm just going to remember my shortcut here. A squared minus B squared. All right, so that's going to be 3 squared plus 2 radical 3 squared. All right, so I got to be careful here. Oh, not plus, not plus. Oh, don't make that mistake. What? Minus. All right, so I'm going to get 9, 3 times 3. All right, and this is where I got to be careful. So if you want to use your chapter 6 exponent rules, you can, but remember what happens to that. The square is going to go to each one of those 2 terms. So this is going to be minus 2 squared times radical 3 squared. All right, and when we multiply a radical by the same radical, essentially what it does, just like over here, radical 3 times radical 3, 1 3 makes it out, 1 3 doesn't. So this is going to be 4 times 3. 9 minus 4 times 3, that's going to be 9 minus 12. That's just going to be negative 3. Oh, is that it? That's it. But it's complicated. It's so much more complicated because you have to fill in the missing pieces. All right, so this is where you got to be really careful. What did you start with here? Well, you're starting with an A plus a B? No, an A minus a B. So we've got to multiply this by a what? An A plus a B. All right, but it's exactly the same, right? So it'll be 2 radical 6 plus 3 radical 2. Okay, so when I multiply this out, I'm going to take the 2 radical 6, I'm going to square it, I'm going to subtract the 3 radical 2 and square it. All right, so that squared is going to hit the 2, so that's going to be 2 squared. And then the 6 squared is going to be just a 6 minus the 3 squared and the 2 squared. And the 2 squared, radical 2 squared is just going to be 2. All right, so now I got to follow PEMDAS. Don't multiply 2 times 6. 2 times 2 times 6. Okay, so that's 4 times 6. And over here, this is going to be minus 9 times 2. So that is going to be, I believe, 24 minus 18. So my final answer there is going to be a 6. Boom. All right. So all of that put together now with these fraction radicals. And the whole thing with math is we like terms to be nice and rational. And so we have this rule that if you are left with your final answer with a radical in the denominator, we are not happy with it. We have to do something called rationalizing. So let's look at the first one first. Let's factor 20. No, they're probably going to share radical 5 here. So I think this is going to be square root of 4 times the square root of 5. Right? And I know 45 is going to be the square root of 9 times the square root of 5. And so that's going to be 2 radical 5 over 3 radical 5. But the radical 5 over the radical 5, they're the same radical. They create a big 1, so we're just left with 2/3. Now the big question is, do I have a radical left in the denominator? If I did, that would be a problem, right? So if I had something, if my final answer was this, let's say it was 2 over radical 3, like that. If that was my final answer, that would not be a good answer because a radical's in the bottom of the fraction. So I have to rationalize the denominator, the bottom of the fraction. I multiply that by radical 3, and I multiply that top by radical 3 because that is just a big 1. So I'm not changing the fraction, I'm making equivalent. I'll make it to a 2 radical 3 over radical 3 times radical 3, like a b squared, but they're the radical, so it's just going to become a 3, like that. All right, so when I look at this problem here, what's the big problem? The radical in the denominator. I can't leave that radical in the denominator. So I have to say, okay, how many terms are there? Well, there's 2 terms now, not 1 term. So the problem with that is that's an a minus a b. So I need to figure out what's the a plus a b. So this is what I'm going to have to multiply the fraction by, the a plus a b. So this is going to be, in this case, radical 7 plus radical 2. And so I'll have to multiply the top and the bottom of the fraction by the same binomial. All right, so when I do that, on the top, I'm going to get my 10 radical 7 plus 2, radical 2. Now, my hint to you is just leave it for the moment. Don't distribute the 10. Just leave it. Figure out the bottom of the fraction first, because if the bottom gives us a common denominator, or sorry, gives us a common factor with that 10, we can simplify the fractions that way, and it'll be much, much easier to deal with. Okay, so let's look at what we got there. All right. So a minus b times a plus b, remember it's going to result in a squared minus b squared. So if I'm going to multiply that denominator, that's going to become radical 7 squared minus radical 2 squared. So here's where I got to be really careful and really think, what do I get? Please don't tell me you're going to get 49 minus 4 and you're going to get 45. No, you are not. Please don't tell me you're going to get the square root of 45, because you're not. Okay? Radical 7 times radical 7 is radical 49, or just 7. Radical 2 times radical 2 is just the square root of 4. That's 7 minus 2. That is 5. All right. So this fraction looks like this now. Now, why did we not distribute that 10? Because you know what 10 divided by 5 is. Oh, so that's going to be a 2 multiplied by radical 7 plus radical 2. Now, you might not see that answer because you're probably going to see the 2 distributed. And you're going to get 2 radical 7 plus 2 radical 2. All right. So first off on the bat, look at your fraction. They're just going to tell you to simplify. They're not even going to tell you to rationalize the denominator. They're just telling you to simplify. Okay, how? Well, don't like the binomial, don't like the radicals in the bottom of the fraction. Get rid of them. Well, what does it mean? It means multiply it by almost exactly the same thing, but identify a plus b and a minus b. We're given a plus, so the other one's got to be a minus. So radical 10 minus radical 5 multiply the numerator by the same value. All right, so I got radical 10 minus radical 5 over radical 10 minus radical 5. Work on the bottom first. Just ignore the top for the moment. Let's figure that out. All right, so there's radical 10 squared minus radical 5 squared. All right, please don't tell me it's 100 minus 25. It's not. It's not. It's not. It isn't. It's just what? 10 minus 5. It's 5 again. Over negative 3 times radical 10 minus radical 5. Now, you might see that as an answer, but you're probably going to have that negative 3 distributed to both those terms. And so you're going to get negative 3 radical 10 plus 3 radical 5 all over 5. All right. What if there's only one radical in the binomial in the denominator? Well, still treat it like an a minus a b or an a plus a b. So what's in the bottom? A minus b. So what's the value we'll multiply by? 2 plus radical 3 over 2 plus radical 3. Okay, so on the top I'm going to get my 7 that I'm not going to distribute yet. Don't distribute it. And on the bottom, all right, this is where I got to be careful. This is going to be, remember, 2 times 2, or 2 squared, minus radical 3 squared. All right, so what is that? Well, that's 4. Radical 3 times radical 3 is the square root of 9, or minus 3. Hey, that's just 1. So the denominator is 1. Yeah, and if the denominator is 1, we could just drop it, and so we're going to be just left with the numerator, which if we distribute the numerator, we're going to get 14, 7 times 2, plus 7 radical 3. Is this looking easier? I hope it is. Okay, let's take a look at number 4. All right, what am I going to multiply this by? I got to multiply it by something. So look at the parentheses here. Or sorry, look at the binomial there. All right, so that's your A and that's your B. It's an A plus B or an A minus B. It's an A plus B. So my denominator that I'm going to simplify by is going to be the opposite. It's going to be radical 3 minus 1. Wait, does it matter? No, it doesn't matter, the order. We could switch it up if we wanted to. We're just going to leave it like that, okay? All right. Radical 3 minus 1 on the top. All right, so when I do the multiplying here, just work on the bottom first. All right, so we're going to multiply the bottom times the bottom. That's going to give us a squared, radical 3 squared, minus 1 squared. All right, so that's going to be 3 minus 1. Hey, that's 2. So I'm going to have 4 times radical 3 minus 1 divided by 2. And if the factors of now those two values are the same, or if we can find a common factor, we can simplify. Can 4 be divided by 2? It can be. So I have a 2 there that I'll distribute. And I'll get 2 radical 3 minus 2. Okay, so I'm hoping this is clarifying stuff for you and making it a little less scary. I'm going to leave you to try the homework that I assigned. And please attempt it. I think I've only seen one student turn it in, so come on, get on it. Because I'm also going to be uploading quizzes for you to take on these two. Show me that you can do it. Good luck.